The two actions here that we can move to their own methods are calculating the area and perimeter of the rectangles. Let's start with area first. The methods will be defined inside the class but outside any other methods. As per the method definition syntax, the first thing we need to mention is the access specifier. I will give the access specifier as public. After that, we need to mention the modifier, which I will write as static. Then the return type of the method. As we are assuming the sides of the rectangle to be integers between 1 to 100, so multiplying them will also result in an integer. Hence the return type of our method will be int. I will name my method computeArea. Next is the parameter list, so I will add the parenthesis. The first input to the method computeArea is the length. I will write it as the first parameter of parameter list like this. Notice that in the parameter list we mention both the data type and name of the parameter. The second input to this method is the width, so I will add another parameter here for width like this. Our parameter list is complete. These variables L and W are referred to as the formal parameters or formal arguments of the method computeArea. Moving on to the body of the method, as method body is enclosed within curly braces, so I will start by adding it. After that, I will write the statement for computing the area. Multiplying length and width gives me the area, which I store in int variable a. Our method is still not complete. One important thing is still missing. We have computed the area, but our method is still not returning it as the output. To return something as the output of the method, we use the return statement. For returning area, I will write the return statement like this. The return statement followed by what we want to return. Now this a will be returned from method computeArea as its output. Looking at the different elements of method definition, they will be like this for computeArea method. Similarly, let's write the method for calculating the perimeter too. The access specifier will again be public. Modifier will be static. Return type will be int. I will name this method computePerimeter. Parameter list will be same as that of computeArea. Next, I will write the method body. Next, I will return it as the output of computePerimeter method with the help of return statement. Both of our methods are completely defined now. But there are two steps involved in using methods. First step is defining the methods, and we have already completed that. Defining the method means that our method is created. Defining the method doesn't mean that the statements in the method body will start executing right away. To use our method, that is, to execute the statements of our method and get an output from it, we need to call the methods. Let's now call computeArea and computePerimeter methods in our program. I will remove this length into width and instead call the computeArea method here. We use the method name to call it. After that, I need to provide the inputs to the method which I mentioned in the parameter list. The first input to computeArea is length, so I will mention length here. Second input is width. This is how we will call computeArea method. When we are calling the method, we need to supply it the inputs that we mentioned in the parameter list while defining the method. Similar to the parameter list of method definition, here also the inputs are enclosed within parentheses and are separated by commas. These arguments or parameters that we use in the method call are termed as actual parameters or actual arguments. So, the formal arguments of method compute area are L and W that are mentioned here in the method definition, while the actual arguments for this method call of compute area are length and width. Formal arguments are used in method definition, whereas actual arguments are used per method call. One important thing to note here is that, unlike the method definition, when we are calling the method, we don't mention the data types of the inputs. If I mention the data types of length and width in the method call, it will give me compilation errors. Let me show it to you. So be extremely careful about this point. I have seen many students making this mistake of mentioning the data types of inputs in the method call too. Please don't do that, as it will cause compilation errors. Data types are mentioned only for formal arguments, not for actual arguments. Notice this assignment part here. int area is equal to, and then we call compute area method, passing it length and width as the input. Compute area method computes the area and returns it back as its output by using the return statement. That value of area returned by compute area method gets assigned to the int variable area. Similarly, let me quickly call the compute perimeter method as well. Now our program is using methods. Let's execute it and check that we are getting the same output as before or not. Our program is giving the correct output as before. Let's go through one iteration of the loops to understand how methods are executed. To start with, length is initialized to 1. After that, width is initialized to 1. Next, program control comes here and calls compute area method. The value of variable length, which is 1, is copied to this first variable L in the parameter list. So L also becomes 1. Similarly, the value of width is copied to W. Notice that the inputs mentioned in the method call are copied in the same order to the variables mentioned in the parameter list. So order of actual arguments in the method call should match the order of formal arguments in the parameter list. The program control enters compute area method now and starts executing its statements. A becomes 1. After that, the return statement transfers the program control back to the method call along with the output of the method. So compute area method returns 1 that gets assigned to the variable area. Program control moves to the next statement. Similarly, compute perimeter method is called. Program control comes to the first statement of compute perimeter method. Perimeter is computed as 4 and assigned to P. After that, the return statement transfers the program control back here and 4 is assigned to perimeter. Next, area, which is 1, is not equal to perimeter, which is 4. The condition of if statement is false and the println following it is not executed. So that's how we define, call and execute methods. You might wonder at this point that the program we wrote initially without methods was also working fine. So what is the benefit of using methods in it? Is it just some fancy way of coding, or are there any real advantages also in using methods? Turns out that methods offer many advantages in programming. We will look at it in the next lesson.